Today's video is going to talk about adding and subtracting rational expressions. The rules for adding or subtracting rational expressions all come from adding or subtracting fractions back when we were in grade school. So if we have something like 3/5 plus 2/7, I couldn't add them without getting a common denominator. So in this case, I would make a common denominator of 35. And so I would have 21/35 plus 10/35, and I would get 31/35. I have to get a common denominator in order to add the numerators together. And so the rules for adding or subtracting rational expressions: get a common denominator. Then add the numerators. Finally, in problems that have variables, cancel common factored expressions. This one's an if necessary, and it's very rarely necessary, but sometimes it is. And so that's something that we might have to do. In order to get common denominators, we often want to factor the denominators first. Denominator. I'm really struggling spelling that in these last couple of videos. Okay, simplify completely. State the domain in problems 1 and 2. So the domain in problem 1 is going to be all x except x cannot equal 2. So that would be negative infinity to 2, union 2 to infinity. Just getting some practice stating domains. Just like it said in the last video, if you can substitute the value in and it makes the denominator 0, that's a domain problem. Now, if we look at number 1, the denominators are already the same. So all I have to do is add the numerators, and I'm done. I can't cancel anything. Remember from the last video, I can't cancel these x's out because they're part of a larger expression. So I'm done there. Problem 2, the domain has a restriction. All x's are fine, except x cannot equal -8, because if I sub in -8, the denominator is 0. So that's negative infinity to -8, union -8 to infinity. Now, if I look at this, I need to get a common denominator, so I'm going to multiply 7 by x plus 8 over x plus 8. So what I'm going to do in this case is, in order to get common denominators, we're going to multiply by a FFU. The fancy form of 1 that we're going to choose in problem 2 is x plus 8 over x plus 8, which, as we know, is really equal to 1. The only difference is when we divide, or when we multiply by x plus 8 over x plus 8, we're multiplying by 1, but we're multiplying by 1 in such a way where x cannot equal -8. But since this problem already had x not being able to equal -8, it's not really affecting anything. So we need to choose our FFUs wisely in order to manipulate expressions. Then I'm going to subtract 2 over x plus 8. And now it's just a matter of combining like terms. So I have 7x plus 56 over x plus 8 minus 2 over x plus 8, which I can write as 7x plus 54 over x plus 8. That's my final answer. I cannot factor the numerator, so I can't cancel it with the denominator. I only even really need to factor the numerator if I'm going to end up being able to cancel it with the denominator. So let's take a look at this. Problem 3, I have x over x plus 2 minus 2 over 2 times x minus 3. So what I'm going to do to make my life a little bit easier is I'm going to reduce that, because there's a 2 in both the numerator and denominator. So I have x over x plus 2 minus 1 over x minus 3. One thing that's important to note is if my denominators are x plus 2 and x minus 3, those are entire expressions. So I cannot just simply multiply the problem or the x over x plus 2 by -3 or 3. I can't do that. I have to multiply by the entire thing. So my common denominator is going to be x plus 2 times x minus 3. So that's important to understand. The easiest way to do this is to just multiply the top and bottom by what is missing. So if I look at x over x plus 2, the thing that's missing from my denominator is x minus 3. So I'm going to multiply the top and bottom by x minus 3. Notice that the x minus 3 wasn't there before, now it's there. If I look at the second part, I had an x minus 3, I'm missing an x plus 2, so I'm going to multiply the top and bottom by x plus 2. I could write the 1 there if I wanted, but I don't need to write the 1 there. So now I have a common denominator. Now I'm going to add the numerators. So I have x squared minus 3x, and then I'm going to subtract x plus 2, so I get minus x minus 2. Notice I have to distribute this negative sign, and that's all over x plus 2 times x minus 3. Let's combine like terms. I get x squared minus 4x minus 2 over x plus 2 times x minus 3. I can't factor the numerator, so I'm done. Problem 4. If I factor x squared minus 4x minus 12, that's x minus 6 times x plus 2. So if I look at this problem, the first term is missing nothing. So I'm going to have x over x minus 6 times x plus 2. And the second term is missing an x plus 2. So I have x minus 6 times x plus 2 as my common denominator. Now I'm going to rewrite this by actually subtracting things. So x minus 3x minus 6. Once again, it's important to note that if I distribute this, I get 3x plus 6, but I have to distribute this negative sign. That's very, very important. So I end up with negative 2x minus 6 over x minus 6 times x plus 2. That can be my final answer. I also could factor out a negative 2 from the numerator, and then that leaves me with negative 2 times x plus 3 over x minus 6 times x plus 2. I could do that if I wanted, but I don't have to, because after I factor out the negative 2, notice that x plus 3 doesn't cancel with anything. So it's not necessary. It's doable. You wouldn't get marked off for it, but it's not necessary. It would only be necessary if you had to cancel something off. Problem 5. So what I'm going to do is I'm going to factor 2x squared minus 5x minus 3. And excuse me, I'm going to venture a guess that it's x minus 3 times 2x plus 1. That isn't rocket science usually. So usually what happens is denominators end up giving you clues for what the factors are going to be. So this last term, minus 56 over x minus 3 times 2x plus 1, I don't have to change anything there. If I look at this first term, I'm missing a 2x plus 1 from the numerator and denominator. So I have x minus 3 times 2x plus 1 is now my new denominator. Then I have minus 8, and that's missing an x minus 3 over x minus 3 times 2x plus 1. So I now have a common denominator for everything. So now what I'm going to do is I'm going to, after I get the common denominator, I'm going to add the numerators. So I have 2x squared plus 11x plus 5. I got that from distributing up here. Then I have minus 8x plus 24. Notice that after I distribute, I have 8x minus 24, but then I have to distribute the negative sign. And then I have minus 56 all over x minus 3 times 2x plus 1. Now I have to simplify. So I have 2x plus 3x, and then plus 29 minus 56 is minus 27 over x minus 3 times 2x plus 1. Sorry, that was x squared. So 2x squared plus 3x minus 27 all over x minus 3 times 2x plus 1. The thought that we have to have is, can I factor this into something that might cancel in the denominator? So I don't have to worry about anything that won't cancel. I just have to worry about the things that might. So if I tried 2x plus 1, that would have to be x minus 27, and that's definitely not going to work. So that one doesn't factor. If I tried x minus 3, this would have to be 2x plus 9. And that actually does end up working out. Notice that if I distribute this out, I get 2x squared minus 6x plus 9x, which gives me plus 3x minus 27. So I have to continue in this problem because something can cancel. So I have x minus 3 times 2x plus 9 over x minus 3 times 2x plus 1. The x minus 3's cancel, and my final answer is 2x plus 9 over 2x plus 1. So that's my final answer for problem 7. Problem 5, I'm sorry. Problem 6. So now I have to get a common denominator. It looks like my common denominator is going to be x times x minus 3 times x plus 3. Oh yeah, and then I have this 3 also. So my common denominator is going to be 3x, x minus 3, x plus 3. So let's take a look. The first term is missing a 3, an x minus 3, and an x plus 3. So I have 1, and then my common denominator is going to be 3x, x minus 3, x plus 3. So what I'm missing is a 3 and an x minus 3, x plus 3. I can just simplify that to x squared minus 9 by distributing it out, and that'll make it easier for me. The second term is missing a 3x and an x plus 3 over my common denominator. So that's 3x, x squared minus 9. I'll write that just to save a little time. And then this last part is missing an x times x minus 3, or an x squared minus 3x. And then that's all over my common denominator. You don't write common denominator. I'm doing that to save time. So I have 3x squared minus 27 minus 6x squared. And then that would be minus 18x. Notice that there's a distributive property with the minus sign. And then I have plus 5x squared minus 15x. All over 3x, x minus 3, x plus 3. So now I'm just going to combine like terms. So I have 2x squared minus 33x minus 27 all over 3x, x minus 3, x plus 3. And once again, I do have to care, at least, I do have to care whether the numerator factors into something with an x minus 3 or an x plus 3.